Page 6 of functions, they're going to start looking at unit conversions in terms of functions. Remember, we did unit conversions earlier, and when we did that, we used the concept that if we multiply by the number 1, then you can multiply by 1 as many times you want, and you don't change the actual value or quantity of something. So if we make a ratio or fraction using two different units, we can put two different amounts of each unit, and as long as they're the same as long as they represent the same quantity, then that ratio or fraction is basically 1, and we can multiply that times a quantity to modify the units. Okay, so if you think back, remember we like put different kinds of currency units one on top of the other as long as they were equal to each other. Like for example, here we have Great Britain pounds, and I think it's like Singapore pounds or something. I don't remember what SGP is. And then we have 2.2 pounds is the same thing as 1 kilogram, for example. So we use these conversions to take a quantity in pounds and change it to kilograms, etc. Okay? So let's see how we're going to do that. In number 1, it says that 1 kilogram is equal to 2.2 pounds. So we're going to use either this one or this one. It says to convert 50 kilograms into pounds. So far we're not graphing or anything, so we're just going to take 50 kilograms and we're going to multiply it times one of these two ratios, and obviously it's going to be this one because it has kilograms on the bottom, and that's the one that is going to help us by canceling out the kilograms on the top there. So we're going to cancel out these kilograms, and then we're left with 50 times 2.2 pounds, and that'll give us a quantity just in pounds. So it gives us 110. So 110 pounds is the answer. Draw a conversion graph of pounds to kilograms. Use x values from 0 to 100 kilograms and y values from 0 to 250 pounds. Okay, so I think I put 10 marks here. 5, 6, 7, 8, 9, and 10. And then the y values is 0 to 250. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I'm going to run out of space. Let's skip by 2's. So do 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 210, no, 220, 240, and 260. Okay, and here I put 1 through 10, but actually it's 0 through 100, right? Okay, now I'm going to find the gradient of the line. So let's plot the point that we have here. One of the points is 0, 0, right? Because if you have 0 pounds, the same thing as 0 kilograms. That's an easy conversion. Then we're going to take 50 kilograms and we're going to convert it to 110 pounds. So 50 kilograms is here, and 110 pounds is right there. Okay? And so that's the second point. And now we're going to draw a line through it. Looks kind of like that. Okay, and then find the gradient of the line. Find the gradient of the line. Okay, if we want to find the gradient of this line, we could put these 2 points into ln reg, and then we could find the equation for the line. Okay, so first we'll do that. We'll use stat, edit, and we'll put in these 2 points. We'll put 0, 0, and then in the other point we'll put 50, 110. 50, 110. And then we will look at the table. Oh, that is the table. We will do ln reg. Stat, stat, calc, linreg, L1, L2, go down to calculate. And it gives us the y equals 2.2 times x. Okay. So if y equals 2.2 times x, then, and they said to write it in terms of p of x. So we have p of x equals 2.2 times x. And 2.2 is the gradient. Okay? Then it says find P75 and P125. So we could take this equation and we'll put it into here. We're going to put the equation in here. We're going to put 2.2x, 2.2x, and then we can even graph it if we want to. Oh, we need to do zoom fit because it's going to be the wrong side from our last graph was mostly negative, so that's why it looks like that. Okay, so here's our line, and now I can find what would be the value in pounds if I put 75 in for kilograms, and I can do that, I can do that by doing trace. So I do trace 75, and it gets, just 75. Just 75. Graph, trace, 75, enter. Oh, it's because it's off the screen. So now I need to adjust it so that it is on the screen. I could use table also. So let's see, for X max I'm going to put like, I don't know, 100. Oh, and now I need to zoom fit again. It's really important that you get good at using these zoom and window functions because we're going to use them more and more next semester, and it's pretty easy to do it for linear functions, but other functions maybe are harder. So learn it well now. Be able to graph functions easily. So now I'm going to do trace 75 to see what the number of pounds is for 75 kilograms. It's 165. Okay, so 165 is the answer for the first one. And then for 125, it's going to be more. I think it's going to be off the screen. Again, it's off the screen again. Oh man, I got to do it again. I should have put a different value I should have put a bigger value for X max. Now I'm going to put X max 200 just so that it's big enough now. Oh, and then I need to zoom fit again. Oh my gosh. Should have done everything bigger from the start. Zoom fit. And then now it's okay. And now I'm going to do trace 125. Trace 125. It's going to be 275. So the other value is 275. Find the model for Kx, where Kx is the weight in kilograms and Kx is the weight in pounds. So it's kind of the opposite of what we were doing here. Instead of starting with 50 and then getting 110, when we put it in the function, we're going to take 110 and we're going to get 50 out. The way you do that is you just do the opposite of this. So for example, instead of multiplying by 2.2, k of x is actually equal to, it's like x divided by 2.2. And if that's kind of confusing to you, you could just use the stat table. And then, so now instead of having 0, 0 and 50, 110, you would have the opposite. You have 0, 0 and you'd have 110 and 50. And if you have that, then now let's do linreg again. Stat, calc, linreg. Calculate. So it gives me 0.4545x. So it's actually equal to 0.4545x, which is actually divided by 2.2. Okay? So we found the model. Now it says to calculate K75 and K100. So we're going to put this function into our y equals. So instead of 2.25, we're going to put 0.4545x, and then we're going to graph. And then we're going to put in numbers like 75 and 100. So what happens if you have 75 pounds? Oh man, I screwed up again. Graph, trace, 75, 34.1. So what if I put in 100? Trace, 100. Got 45.45. Okay? So those are the two values for F. Let's move on to the next one, number 2. The exchange rate for pounds sterling to Singapore dollars, SGD, is 1 pound is equal to 2.05 Singapore dollars. Find the number of Singapore dollars equivalent to 50 GBP. Okay, so 50 GBP times some ratio which has the same quantity above and below, and we're going to put 1 Great British Pound on the bottom, and we're going to put 2.05 Singapore dollars on top. Okay, and then that would give us 2.05 times 50, which is, I'm going to use the offline calculator because it's faster. 50 times 2.05 is equal to 102.5. Okay, and so that was the answer to A. Now B, it says to draw a conversion graph from GBP to SGD. Use X values from 0 to 100 and Y values from 0 to 250. So we'll put 0 to 100 and 0 to 250. So this is Great British Pounds, and this is SGD. And we know that if you put in 50 Great British Pounds, which would be there, it will give us 102.5 SGD, which would be 1, 2, 3, 4, 5. It would be about there. Okay? So if we made a line from 0, 0 to that, because we know that 0 Great British Pounds is equal to 0 SGD, then we get that. Okay, now why don't we put the model in the calculator? And the way we find the model is we use linreg. So stat edit, and we're going to do linreg. 0, 0 is the first point, and the other point is going to be 50 and then 102.5. 50 and 102.5. 102.5. And then we're going to do stat calc linreg. And then we're going to go to calculate. And we get y equals 2.05 times x. So we'll get s of x is equal to 2.05 times x. Okay? Oh, yeah, we skipped that step, but we just did it. Okay, and so now we're going to put that equation in the calculator, in for y equals. So we're going to put 2.05x. Okay, and then we're going to graph it. And then we're going to find the value when the input is 80 and the input is 140. The input being Great British Pounds. So how many SGD if we have 80 Great British Pounds? It's going to be 164. 164. What about when we have 140 Great British Pounds? I hope I made it wide enough. I think I did. 287. Okay, so those are the two values you get out of the model that we made. Find the model for P of x, where P of x is the amount of money in GBP and x is the amount of money in SGD. Okay, now remember, that's just like, you just invert the gradient. Okay, but if that confuses you, what you could do is you could just, in stat edit, instead you could say, oh, okay, 0, 0 SGD is equal to 0 GBP, and then 102.5 SGD is equal to 50 GBP. Okay, you could invert that. And then you do stat calc, linreg, and then I'm getting kind of tired of like typing in the equation, so I'm going to use it here. You remember how to do this? You go alpha F4 or something, and then you choose Y1. And then now, not only will it show you the equation, it'll put the equation into the Y1 slot. Okay, so it says it's going to be, okay, so P is actually going to be 0.488x. Okay, and if we've already put it in there automatically. There it is, right there. You can't see the x because it gave you every single digit. So there's another advantage to doing that, right? So we got that in there. We can graph it. And then we're going to find out what the amount of pounds is when you have 180 SGD. So we're going to put trace 180, and it gives us 87.8. Okay, it's always good to write units on these. Okay, so these were GBP. These were SGD, I think. Okay. Moving on to the last one on this page. The exchange rate for pound sterling to US dollars is 1.55. Find the number of US dollars equivalent to 60 GBP. Okay, so 60 GBP. We're going to multiply this times 1 GBP per 1.55 US dollars. Okay, so 60 times 1.55. 60 times 1.55. That gives us $93. Okay. Then it says, draw a conversion graph of GBP to USD. Use the x-axis for GBP with from 0 to 80, and the y-axis for US dollars from 0 to 140. Let's see, 0, 1, 2, 3, 4, 1, 2, 3, 4, 80. Okay, so we'll do, oops, that's not 80. 80. This is 40, this is 80, and this is 0, and this is GBP. And dollars would be 0, let's see, did I put 14 spaces here? 2, 4, 6, and no I didn't. So it's going to be, this would be 40, this would be 80, this would be 120, and this would be 140 right here. Okay? And then so this would be dollars. Okay. Find the number of US dollars equivalent to 60 GBP. We got $93. Draw a conversion graph. So we got 0 to 80 GBP, and we got the y-axis, we got 0 to 140 USD. Okay, and let's see, find the gradient of the line, write down the model. Okay, so we're going to use linreg to do that. We'll do stat edit, and we're going to put 0, 0, and then we have the input amount is 60 and the output amount is 93. So we'll put 60 here, and then put 93 here, and then we'll do a stat calc linreg, and then again let's put the equation directly in there because it's easier than typing it in. It's just hard to remember this. It's like alpha F4 Y1. It's kind of hard to remember. Okay, so now if we go, now we have our model. So it says the model for u of x is going to be 1.55x. Okay, and then it tells us to check out or to find U300 and U184. So we can graph it. And you could actually do this with table also, but you would have to scroll down to find 300 or 184, and it would just take a long time. So maybe it's a little bit easier to do it with trace. So to trace 300, oh, I'm going to go off the screen for sure, because I only put x max equals 200. So I'm going to put x max equals something much bigger. Let's put like, looks like they're going to ask me 7,000 later, so I'm going to put like 8,000. And then I'm going to do a zoom fit. Zoom fit, zoom fit. There it is. Okay. Now I can graph again. And now when I graph, I'm going to check out what is the number of dollars for 300 or 184 GBP. Oh my God, this is going to take forever. Look at it. It's struggling. I'm going to pause this. I had to readjust the window so that it wouldn't be so huge. Okay, so now I'm going to try 300, trace 300 to see what I get there. Trace 300. Oh, man, I'm off the screen. This is kind of a pain, isn't it? Okay, there's something to be said for algebra. Okay, I'm going to put 300, trace 300. Oh. Now I need to graph that. Here's one. Okay. Trace 300. 465. What about 184? And this is $465. What about 184? Trace 184. $285.20. 285.20. Okay. Find the model for P of X, where P of X is the amount of money in GBP and X is the amount of money in dollars. Okay, again, this is just the inverse. So you could write, P of X is equal to 1 divided by 1.45x, or you could go to stat lin reg and just invert everything. So instead of 0, 0, now you're going to put $93 input gives me $60 GBP 60 and then I'm going to do stat calc linreg, and then I'm going to put y1 here, alpha F4, enter y1, and then I'm going to calculate I wonder if I pressed calculate last time. I don't remember if I pressed calculate. And then I can graph it. And now it asks me for some. Oh, and let's see what the equation is, because I didn't write it down. The equation is 0.645x. 0.645x. Okay. Now we're going to find out what the value is when x equals 250. So we're going to go trace 250. 250. And it gives me 161.3 GBP. What about 7,750? Now 7,750, if I do that here, it's going to take forever because it's going to try to graph it out that far. But I could look at the table. I could look at it through the table. Now the problem is 7,750 is way down there, but I can set my step size to something bigger, like 250, and then I might be able to find it without too much problem. Do you see, now it jumps by 250s, and now I'll get to 7,750 in much less time. So this is an alternative way to do it, but if the number's too big, you got to be clever about the way you jump. 5,000. Okay, And of course, there's always algebra. I'm avoiding algebra at all costs here, but you could just take 0.645 and multiply it times 7,750. If you did 0.645 times 7750, then that would give you 5,000 GBP also. Okay, so that's it for that page, which was page 6.